Okay, hi class. This is Mr. Mellinger with your lesson for Thursday evening on atomic and molar mass, and we had a brief lecture on it. This is really just a repeat of the lecture, but it'll go over some of the concepts we talked about. So what we're trying to do is figure out the number of the mass of an atom here, and how many atomic mass units it is, how many atoms it has, and how many molecules it creates. So we're on the microscopic scale here. We're dealing with atoms, molecules, and mass measured in atomic mass units. Those little tiny units that are the mass of a single proton or neutron. So we're dealing on what's called the micro scale here. So if I take the formula for glucose, which is just a form of sugar, there's many forms of sugar. Glucose is one of the most common ones we deal with. It's what's created by plants in photosynthesis. We see it as a formula of C6H12O6. You're not expected to know why it has a formula of C6H12. It's the way nature made it, and we just accept that's what it is, and we learn some of these things. You're seldom expected to memorize these formulas. It doesn't hurt, though. The more chemistry problems you do, the more of them you'll just know off the top of your head. But we want to figure out what that weighs. What's the mass of that molecule? So we just simply count the atoms, and we multiply by the atomic mass of each of the atoms. So carbon, there's 6 atoms. Each one has a mass of 12.01. You get that off your periodic table. Hydrogen's 12 atoms, and the atomic mass of that is 1.01. You get that off your periodic table. Multiply those two. And finally, oxygen, there's 6 of those atoms, and that has an atomic mass of 16. And multiply those two together. So you end up with the total masses of each of those elements over in the right-hand column. And if you add them up, they give you the mass of each, the mass of the total glucose molecule. So this is just a simple exercise in computing the mass of a molecule, which is just simply a number of different elements put together. Okay, next up. So now what we're going to do is we're going to get into the concept of molar mass, and we're going to relate it to atomic mass. Moles are a very large number of atoms or molecules. It's 6.022 times 10 to the 23rd. That number's on your assignment sheet. And what that is it's a big enough number that we can actually physically see it or weigh it on a scale. A single atom or molecule can't be seen or weighed, but if you take a big enough bundle of them, you can actually weigh them and see them. So we can actually work with them in what's called the macroscopic world. That's the real world that we live in, not the little tiny world of atoms and molecules. Okay, so what they found was there's a magic number they settled on for that standard number of atoms or molecules that they want to use, and that's 6.022 times 10 to the 23rd. It's a huge number. The question is, why did they pick that huge number? They could have picked another huge number. They could have picked any huge number and called that a mole. So why did they pick this one? So you're going to see that here in this demonstration and in the exercises that you do this evening. So let's take sulfur dioxide, very simple compound, and it has the element sulfur, and there's one sulfur atom in sulfur dioxide. The mass, you get this from your periodic table, is 32.07, so you multiply that by 1, and that means the mass of the sulfur in a sulfur dioxide molecule is 32.07. Now there's 1 mole of sulfur dioxide. We just decided that we're going to multiply that one atom by 6.022 times 10 to the 23rd, and that'll give us 1 mole of sulfur. I'm going to get to the molar mass in a second and the number of atoms, but let's go on down to oxygen. And the number of atoms of oxygen in SO2 is 2. You take the atomic mass of oxygen, which is 16, multiplied by 2, you get 32. And if we decided that we don't want to work with two atoms of oxygen, we want to work with 2 moles, then we simply multiply the 2 atoms by 6.022 times 10 to the 23rd, and now we have 2 moles. Okay, we'll get to those right columns in just a second. So the entire molecule, 1 sulfur and 2 oxygens create 1 SO2. Again, to emphasize this point, you don't simply add the number of atoms or molecules together to get SO2. It's not 1 plus 2 equals 3. What you're saying is you want to create 1 SO2. So you want to create one motorcycle. So you need 2 wheels and 1 engine to give you 1 motorcycle. For SO2, you need 2 oxygens and 1 sulfur to give you 1 SO2. That's the complete unit of sulfur dioxide. Okay, the atomic mass, that you do add. You can just simply add that together. And when you add 32.07 plus 32, you get 64.07. So that is the atomic mass in AMU for sulfur dioxide. But again, that's too small for us to work with. There's no scale that can measure 64.07 atomic mass units. So what we said was we were going to, instead of working with single molecules, atoms or molecules, we're going to work with moles. And so we simply multiplied by a mole, and over here in the middle column, we have 1 mole of sulfur and 2 moles of oxygen, and they get put together to create 1 mole of SO2. That's not the magic of 6.02 times 10 to the 23rd. The magic of it is this, that if I take the mass in atomic mass units, 32.07 for sulfur, and I multiply that number of atoms by 6.022 times 10 to the 23rd, Avogadro's number, a mole, I'll end up with exactly the same numeric value in grams, 32.07. There's only one number of atoms or molecules that you can multiply the atomic mass and atomic mass units and get the exact same number value, but in grams. And grams is a standard unit of mass that we use in chemistry. So it's very important that we be able to convert to grams. So that's what makes 6.022 times 10 to the 23rd special. It converts for oxygen. Let's look at oxygen. It takes 32 atomic mass units for a single oxygen atom. For the O2s, for the 2 oxygens that you have there. That's for the 2 oxygens. And if you multiply that by a mole, you end up with the exact same number, 32, but now it's in grams, something that we can measure on our scales in the back of the room. So the total molar mass, again, is identical to the number for the atomic mass for SO2, is 64.07, except for molar mass, it's in grams. So molar mass is the mass of a single mole, or it's the mass of the moles in grams. Now, one last thing we might want to add on is how many atoms or molecules do we have. So if we have, for sulfur, it says we have 1 mole of sulfur, so that's 1 times 6.022 times 10 to the 23rd. Okay. For oxygen, it says we have 2 moles. So you multiply 6.022 times 10 to the 23rd times 2, and that'll tell you how many oxygen atoms you have. And finally, for SO2, you have 1 mole of SO2. You multiply that by 6.022 times 10 to the 23rd, and that tells you how many sulfur dioxide molecules you have. So now that you know these relationships, you can figure out some things. It's almost like cooking. Sometimes you want to make more than one cake, so you need more ingredients. So let's look at this. If we look right there in the center bottom, it says we have 1 mole of SO2. So to make 1 mole of SO2, we need 2 moles of oxygen, we need 1 mole of sulfur, we need 32.07 grams of sulfur, we need 32 grams of oxygen, and that 1 mole of sulfur dioxide will have a mass of 64.07 grams. So let's say I wanted to make 2 moles of sulfur. Then I'm going to change the sulfur moles to 2. And let's say I wanted to know how many moles of oxygen that would take. Well, in order to make 2 moles of sulfur, I'd have to multiply 2 times 1 for sulfur to get 2 moles of sulfur dioxide. So I'd have to multiply the oxygen by 2. So 2 times 2 is 4. So to make 2 moles of sulfur dioxide, I need 4 moles of oxygen. You'll notice I need also 2 moles of sulfur. What about if I wanted to know how many grams of oxygen I needed to make 2 moles of sulfur? Well, if I multiply, if I want 2 moles, then I have to go up to the grams of oxygen, which is 32. That's how much it takes to make 1 mole, and I have to multiply that by 2. So 2 times 32 is 64. So to make 2 moles of sulfur dioxide, I would need 64 grams of oxygen. Try to do this one. How many moles of sulfur would you need to make 3 moles of sulfur dioxide? Well, if I multiply the sulfur dioxide moles by 3 times 1 is 3, I'd have to multiply the sulfur moles, which is 1, by 3. So I'd need 3 moles of sulfur to make 3 moles of sulfur dioxide. Okay? If I want to make 1 cake, I need 1 cup of sugar. If I want to make 3 cakes, I need 3 cups of sugar. That's all that's going on here. Let me give you one last one in this example, and you're going to work a lot of these on your assignment. What if I wanted to make 4 moles of sulfur dioxide? How many grams of sulfur would I need if I wanted to make 4 moles of sulfur dioxide? Okay, and the answer would be, if I want to make 4 moles of sulfur dioxide, I need to change, I need 4 times 32.07, that's the number of grams of sulfur. For 1 mole, I need 4 times that many. So I need 4 times 32.07, which is 128.28. So that's how this works. It's just a simple understanding the relationships between atoms and molecules on the one hand and moles on the other hand, between atomic mass units on one hand and molar mass in grams on the other hand, and then figuring out how much of each of the elements that go into sulfur dioxide you would need in order to create it. And you'll be getting a lot of practice on this. So do as many of these as you can tonight. Try to do them all, and we'll share out as a class tomorrow. I'll have each group do one of these. So have a good day, and we'll see you tomorrow in class.